so don't worry, I'm not impersonating Neil. You will get the original in a minute. I have the honor to introduce our next speaker, Neil. So Neil, I think you all know him from his work in machine learning, but he's also a very interesting character with an interesting way how he got to machine learning. He started working as an engineer on an oil rig, then afterwards decided to do a PhD with Chris Bishop. While he was doing the PhD, Chris moved to Cambridge, and this is also where I got to know him. He was very, very friendly. I came there, I didn't know many people. I think the very first person in Cambridge who invited me to his house was Neil. And of course, when you're invited by Neil, the good thing is Neil is not cooking. So we got very good Italian food, and we've become friends ever since. And so Neil, of course, is world famous for his work in Gaussian processes, but more recently also for all the thought that he put into governance of AI, into governance of data. And he's a very, very broad thinker, studying the history of things. And he has thought very deeply in the last years. Every time I met him, he told me about his current thinking about his book, and he was rewriting it over and over again. I think every sentence must have been polished very much. And he's thought very deeply about these issues. And I think maybe I don't want to anticipate what he's going to tell, but I think it's going to be something deeply human and not just a technocratic talk about AI. So we're very much looking forward to your talk, Neil. Oh, and I forgot to say he's now a professor in Cambridge.
Thanks, Bernard. And really nice to be at this event, because so much of what I think we hope to achieve is going to be achieved through ELLIS. So, as Bernard says, I've been thinking about these things, and I even have now I have a T-shirt with the book cover on it. I've stopped thinking and start producing merchandise, so you can tell the book's finished. So, the notion of the book is the following. So there's a sort of idea that Henry Ford, and this is apocryphal, if he'd been asked what people wanted out of the car, they would have said a faster horse. And so if you project that onto artificial intelligence and you come up with the idea, what do people want out of artificial intelligence? Do they want a smarter human? And what does that even mean? So the idea of the atomic human is to take a look at that question, but from the following perspective. That if every time we invent a computer that does something that we used to think of as unique to ourselves, we're cutting something away from us. If we keep doing that process, then is it like Democritus's atom? So Democritus was I think 300 BC, Greek philosopher. He wondered what happens if you cut into a material like a glass. And if you keep cutting each half and cut again, do you eventually get to a point where you can no longer cut? And he called that atomos. And of course, we get the modern concept of a physics atom from that. But what happens if you apply that cognitively to us? Is there a point at which you can't cut? And I guess, I maybe pause there and put that to the audience, because I always find it interesting what different audiences say. Does anyone have an idea of, you could just shout it out, you don't have to wait. What could you not cut? What can we not give to the computer? It's always computer scientists and nothing. we're Turing machines, so it's fine.
Technically, we are currently inside a computer simulation. Our bodies are running on one computer, and our minds are running on another computer. So
Maybe. Well, I think the reason we're not in a computer simulation is the compute requirements for the simulation would be greater than the universe can hold up. So I think compute is key there, but I don't go into that too much in the book. Other thoughts that are perhaps ones that non-computer scientists might have? Okay, so I'll give you my thought. So I think that the thing the machine can't take from us, any capability you name, like ability to play chess or do mathematics or etc. I think that the computer can take that. Eventually we can work out how to build computers that do that. What it can't take from us are the two following things. our limitations and our vulnerabilities. And by what I mean, because our limitations are baked into who we are. We've evolved with these limitations. Our intelligence has evolved in that context. And it's those limitations that define us, not our capabilities. So a lot of what you hear around the arguments around AI talk about our capabilities and matching them with the machine. They don't tend to talk about our limitations and our vulnerabilities. But I'll focus initially on the limitations. And I'm going to start with this story that some of you may recognize to try and illustrate the notion of limitations. So this book is by a gentleman called Jean-Dominique Bauby. It's called The Diving Bell and the Butterfly. And Jean-Dominique was the editor of the French magazine Elle in 1993. He suffered a brainstem stroke, and it destroyed his ability to move. So the brainstem is very interconnected with the motor system. I think it's all sort of vertebrates have them. And he was bedbound. And he was in a state that we would refer to as a locked-in state, which I think is a state of great fascination for us. What would it mean to be in a state where you can think as much as any one of us, but you can't communicate? And the remarkable thing about Jean-Dominique Bauby is he told us what it was like to be in that state, because he wrote this book, his autobiography, after he became locked in. And it was also made into a film. I've only read the book, I've not seen the film. But the book's really remarkable. And in the book, he talks about how he feels. And actually, and see if I get the French right, where's Florence, see if she frowns, la scaphandre. Is that a correct pronunciation? Le scaphandre. I always get, we don't have genders in. It's turned out to be an advantage in the long term, but we don't have genders. Le scaphandre, which actually means more of a diving suit of the sort of type Tintin would wear when he went for Red Rackham's treasure, right? So these old-fashioned diving suits. And what Bauby is saying is he feels like he's in this diving suit physically. He's constrained. He can't physically move. All he can do is sort of tug on the hose to communicate to surface, because the only thing he could move was one of his eyes. So one eye was sealed shut, but he could wink the other eye. And he wrote the whole book by winking at letters of the alphabet. So one word at a time. And I counted the words in the book. It said it took him 10 months, 4 hours a day. And then given the amount of words he created, he was writing at a rate of about 1 word every 2 minutes. Now, because you're all computer scientists, you're thinking, I could come up with a better scheme. Possibly you could, but that's how he wrote the book. And here he is with his assistant writing the book, winking away. And I think that what's interesting to me is when we think about that, and we think about that state, and the other piece of that state is what he calls the butterfly. And the butterfly, for him, is his ability to think, where he is free. So the locked-in diving suit is how he's constrained, physically constrained, but mentally free. He can imagine, he can remember, and he talks about how that feels to remember experiences he's had. Now, the point to me is you are all in exactly the same state. You are not mentally incapacitated in the way Jean-Dominique Bauby is, but in comparison to the computer, you are in exactly the same state as Jean-Dominique Bauby. And of course, we can look at that because we can look at the sort of Shannon information content of words. And Shannon estimated that English words contain on average of 12 bits a minute, 12 bits a word. Now, I'm going to assume French words have roughly the same information content. I mean, up to the estimate, I'm sure it's roughly correct. So this means Shannon is communicating with us at a rate of 6 bits per minute, which is not very fast. Now, I'm communicating with you, if I'm doing a good public speaking rate, probably around 300 times faster. So around about 2,000 bits a minute. So 150 words per minute is roughly what people suggest for speaking. It will vary. So quite a lot faster, 300 times faster than Bauby. But the comparison that's interesting is not between me and Jean-Dominique Bauby, but between me and the machine. So this is a Colossus Mark II being operated by Dorothy Duboisson and Elsie Booker. And it was designed by Tommy Flowers and programmed and operated mainly by women in Bletchley Park. And it enabled one of the most important decryptions of the Second World War, which almost 80 years and 2 weeks ago triggered the invasion of France by decrypting Adolf Hitler's commands to Rommel to stay put. Now, as soon as we've invented the machine, the interesting thing about the machine is it's computing at light speed. Now, at this time, this computer is isolated. It's very much locked in. It has no other computers to talk to. Its information is being provided by paper tapes, which contain the encoded messages. But as soon as computers began to talk to each other, they didn't use sound to communicate with each other. They used speed of light. The speed of light is how many times faster than sound? 1,000,000 times faster than sound. So right from the very first communications, computers were operating millions of times faster than us in terms of bits per minute. So the comparison that's interesting here is not a comparison just between us and Bobby, we're 300 times faster than Bobby, but between us and the machine. So I'm communicating at around about 2,000 bits per minute, but when we look at the computer, because it's using speed of light to communicate with other computers. We're using speed of light within our bodies to some extent across our neurons, but speed of sound across ourselves as individuals. And then we look at the sort of how much faster. Well, you can see 1 gigabit Ethernet, which is now slow Ethernet, is 30 million times faster than a human. 10 gigabit Ethernet is 300 million times faster. So yes, you are computer scientists. You did very well. On top of that factor of 1 million, we've created coding algorithms that are more efficient than speech. And there's another 30 to 300 times factor over the fact that we're using light communication between computers. So computers are already intercommunicating with one another at these extraordinary rates. Now, just to give you a sense of that, if we turn this into money, Jean-Dominique Bauby is earning $6 a month. That's his bandwidth equivalent. We're earning $2,000 a month, roughly amount that many PhD students have to live in, many families in many countries. And the computer is earning $60 to $600 billion a month. So now, when people say these ridiculous things about intelligences that are many orders of magnitude better than ours, and these are our futures, and AGI, and etc., that already happened by the only single way we have of measuring what's going on, which is to rank information. That already happened. And we're already subject to the consequences, because machine intelligence sees us in a very different way to the which we see each other, because it sees us using many millions of times more data about us than we use about each other. And this limitation is sort of utterly baked into our intelligence. So when we think about how we overcome this limitation, well, we do have, the thing I didn't say on this slide, is our communication is low, but our computation is high, because we're using neurons. We're using electronic communication in our head, many millions of neurons. And when we compare how big a computer it would require to simulate a brain, you're looking at pretty big computers, some of the fastest computers available today. So the amount of computation that's going on in our heads is enormous. So this is my best estimate. Like if a computer was to try and communicate with one other computer, 1 second of computation that it could do at the speed of a typical machine, and I made this calculation a couple of years ago, it would take 20 minutes to communicate every calculation it could make in 1 second to another machine. So that's like all its thoughts, all its computation. But if a human, if I was to try and communicate, and of course I've had to make lots of interesting estimates around simulation, but my estimate of if I were to try and communicate to you all the operations of inside my head, brain, that's a bread, isn't it? It's a combination of a brain and a head, bread. Or a hane, in my hane. If I were to try and communicate everything that was going on in my brain to you, and if I was to say it at 2,000 bits a minute, it would take 5 billion years to communicate 1 second of thoughts. So in this way, I call this the embodiment factor. We're heavily embodied, and of course we think about embodiment in terms of robotics, and that's something else the book talks a little bit about. But we're heavily embodied just in terms of our communication ability. We're isolated from each other. We're isolated. We're like a weird networking ecosystem with massively high compute nodes with massively low bandwidth communication between each other. So how do we get around that? Well, in a simple conversation between two people, if I'm going to try and communicate with you, what I have to do, first of all, is I have to have in my head an idea of who I'm communicating with. And by thinking about who I'm communicating with, I can think about what you know, and therefore what it's useful to say. So I can use my big brain, and by this notion, we all have big brains. Cats have big brains, you know, lots of compute up here. I'm not any different from anyone else. To think first about what to say, and then choose carefully about the thing I say, given my knowledge of who I'm talking to. You will have a sense of who I am, and also a sense of who you think I think that you are. And you will use that in interpreting the message. You combine what you hear from me with what you've heard, what I've said, and then in response, you sort of say something else. And one of the things I think is fascinating about it is it's a very dynamic thing when humans are talking on a shared level. Of course, this is one way now, but when two humans are sharing understanding, it's dynamic, it's interactive in a very interesting way. So I sort of absorb that and I say something else, you absorb this and you say something else. Now, when it works, it's beautiful. And when it doesn't work, we end up swearing at each other. Now, that swearing comes, for me, I think, the biggest arguments I've had are with colleagues I really respect who are working on something similar to me, but are making a different decision about how to do it, because for reasons I don't fully understand, their objectives are slightly different. And this often happens, say, between machine learners and statisticians about what's the right choice of next model decision. Well, because the machine learner's trying to optimize for prediction, the statistician's trying to optimize for interpretability, we make slightly different decisions. If there's a total misunderstanding between the two, you don't tend to end up arguing. It's only when there's a slight mismatch that these arguments sort of occur. But it's because these arguments, the discussions themselves are dependent on all these shared ideas. So, of course, when we communicate with each other, we're rarely sharing facts. We're normally sharing who we are, what we think, things about what we'd like to do. Because once we've shared those ideas, we can reduce the amount of communication. I mean, and actually, I have to say, I feel very privileged to be here in Finland because the Finns are the masters at this. They virtually, you know, two Finns can sit there together saying nothing for hours, but just with a shared knowledge of, you know, it feels to me, as an English person, I know what an Italian feels like when they come to England. But as Aki, who's somewhere here, I can see Aki at the back. I was making this comment once at one of his PhD students' graduation, and he said to me, the reason Finns don't talk very much is because if you're comfortable with the people you're with, you don't have to say anything. And that's absolutely true. And that's the reason that if you're with people you're close to and care about, you know just to go and make them a cup of tea. You don't have to ask them. Right? You know what they want because you know who they are and you can anticipate. And that's what we do as human beings. We think about each other and we care for each other, hopefully by thinking in that way. But this has some sort of interesting effects in terms of the way we think about other intelligences. So my favorite, or the example I use in the book is you know, this is a widely used example around AI, but I'm not using it in the creation example around AI. I'm interested in only one of these figures, not the created, but the creator. So we're told about these intelligences. We're told in these ancient books about these deities that exist, these intelligences that are outside us that have all these properties. And when it comes to depicting them, we think, oh, well, that's clearly a bloke with a beard, isn't it? I mean, the absurdity is extraordinary because you're told about this entity that is an intelligence beyond your imagination, yet we struggle to imagine any intelligence that isn't in a human form. And that's because we anthropomorphize these things. So we're constantly projecting because we're constantly used to communicating with complex entities in an anthropic way. And that's that's why we're getting these weird, bizarre images. I think of it as first order empathy. Our sense is that when we're communicating with another entity, the most simple form of empathy that, you know, we can do is just to assume that entity thinks like us, right? And that's like, and their motivations are the same as us. So when you hear people talking about AGIs and what these things are going to do when they take over, what you're getting is a projection of what that person would do if they had such power. Just remember that. And so when we're hearing from these Silicon Valley CEOs, people who have based their entire lives on acquiring such power and wielding it in these ways, it's unsurprising that they come out with quite apocalyptic visions of what that means. I think when you hear from a lot of regular people what one would do with such power, you get quite a different perspective. But it's still misrepresentation because, of course, all those needs and wants and desires are particular to our condition that requires us to be information isolated from each other. Machines are not information isolated. And in fact, they bring in a very different set of problems. So if we go back 100 years, or more to the sort of foundation of when we first started acquiring data in society and we start looking at the domain of statistics, one of the problems we had with early statistics is we are so keen to acquire information in this very active and sort of, as I was saying earlier, it's a sort of bi-directional way that we expect to sort of intervene with a system and it responds. That when we acquire data from cities to try and work out which city was poorest or which city was richest, we ended up misleading ourselves by acquiring data that misrepresents this sort of notion of lies, damn lies, and statistics. And actually, we had to work very hard. The field of mathematical statistics is all about how to temper the human instinct to misinterpret data. But the reason we misinterpret data is we want to dig into it. We want to find more because we have this low information bandwidth, right? Now, the computer, though, sees data in a very different way. So the computer doesn't have to do that because it can just collect vast statistics. So it doesn't need to overinterpret what data is showing. It can look at data and sort of say, oh, if you put a provocative picture at the top of a post, then people will click on it. It can see that just by A/B testing at scale, right? And it just has to use its very large information bandwidth to work out that's going on. So this sort of emergent world that we've been in is this world of classical statistics was mediating this link between us and data. And now we've been faced with this world of data science, which has been highly disruptive because it's now trying to mediate a link where it's, first of all, the data is going into a machine and then it's being presented to the human again, with all those recurring possibilities for manipulation. And we're forgetting about AI or anything here, just all the recurring possibilities for manipulation with maybe simple machine learning algorithms that we've seen manifest in social media. And not because anyone was evil, because people just said, oh, well, let's increase interaction. Let's do stuff that people enjoy, right? And so large-scale A/B testing found particular foibles in the sort of things we enjoy are the things that confirm our biases and, cause us to sort of feel liked by other people who think the same and cause challenges, right? Or fake news that confirms our biases. So unfortunately, that's not great, right? Because what's going on there is that you're just sort of recreating this world where we used to be manipulated by statistics, but now you can be manipulated by a machine that has access to vast quantities of data. And I've argued for a number of years, you'll find it in many of my talks, that the role of data science is to try and get to the position that statistics took us to my quote is lies, damn lies, and big data. That's the modern version of lies, damn lies, and statistics. And we need to get through that, and that's sort of the job of computer scientists collaborating with statisticians and everything else. So that's point one about what's going on in society and where it's coming from. And the challenge, I think, that we have here is that this ecosystem is mainly controlled by very few entities within society, large, big tech companies, right? Point two, our vulnerabilities. So when it comes to our intelligence, one of the things I can guarantee you all is you're all going to die. The other sad thing I can guarantee you all is that you will be losing people who are close to you. I mean, I don't want to guarantee it because it may not happen to you, but if you live a long life, it's going to happen to you. And these are some of the most significant moments in our life, and we don't normally talk about them in machine learning conferences or when we're building artificial intelligences or anything else. This is an apocryphal, all my quotes are apocryphal, lies, damn lies, and statistics is also apocryphal. For sale, baby shoes never worn. Which novelist apocryphally wrote this 6-word novel? Hemingway, yeah. Because we like to embody any quote in a physical form, and Hemingway's the novelist physical form we like to use for apocryphal novels. For sale, baby shoes never worn. That's 72 bits of information, right? But the meaning of those words is contingent on your the fact that you're human, what your human experiences are, whether you've been through that experience, and why did they make the sale, all those things. As I talk about this, the hairs on the back of my neck go up because I'm a human, and I can imagine what that would feel like for another human. And the fact that we're exposed to that type of vulnerability alongside many others is an integral part of our intelligence. So when we want other people to make decisions about us, we want those decisions to be made by entities that can imagine these experiences. And I don't mean imagine in terms of, oh, it read a lot of Shakespeare, so it's got some impression of Romeo and Juliet. I mean imagine in terms of are subject to the same vulnerabilities. And that's an intrinsic part of our society. If you look at even our laws around artificial intelligence that already exist, such as GDPR, talks about consequential decisions being made, being explainable, but I think more importantly, being made by human beings. Consequential decisions being things like whether you get to go to a particular university, whether you have a particular bank loan, what your health treatments are. Now, all of these are things that humans will also get wrong, because there are no right decisions for many of these complex circumstances. There are the best decisions we can make given the evidence. So there's a tendency to want to return to what people did in the past, which is at some point when it gets too complicated, you go, well, let's just ask the gods. This person, there's conflicting witness statements. It's in the Code of Hammurabi, 1700 BC. If witness statements are conflicting, you just throw the person in the river, and if they're guilty, the gods will absorb them. Now, that's a kind of nice way of dealing with the complexity of the situation, handing it off to the gods. And what you can see is this desperate desire in society to hand it off to AI. Sort of trial by ordeal, but where AI is the one that is deciding the outcome. Now, it is just simply not the case that an AI can get everything right all the time, for the same reasons humans can't. And in fact, to the extent that we are seeing this ridiculous term, glimpses of AGI, all we're seeing is computers that have reconstructed our concepts of the world by reading things that we've written. So the glimpses of AGI are computers copying the way that we make errors. Copying our ideas and our concepts, not building anything from first principles, just saying, well, this is how humans cut through. These are the concepts they use, notions of gods or notions of whatever else. And I can now pick these up. I've reconstructed them. I had to reconstruct them to try and reconstruct text. Now, I think that's an incredibly useful technology. We'll come back to that. But it is just a reconstruction. To the extent it's intelligence, it's a reconstruction of human culture, which itself has really interesting properties and intelligence, particularly of the form, not provably correct. We have a load of truths that we live by. Different cultures live by different truths. Each of us believes in a different set of things, not because they're true from first principles, but because they're handed down to us from people who lived before as useful ways of looking at the world that prove over time to allow us to sustain ourselves. Now, if we look at them as we did do across the last couple of centuries, last 3 centuries, with a reductionist, rationalistic point of view, we can sometimes find flaws with these things. But we can also undermine cultural ideas that have protected us. Things like animistic beliefs, where you think, don't cut down the tree because it's got a spirit in it. Now, okay, I don't believe trees have spirits in them. But if you have groups of people who believe that, guess what? They're a lot nicer to their trees than groups of people that don't. And one of the horrific things I think we do as a society is impose these technologies on people and don't ask them what they want. So Jess Montgomery, who's here, she led the Royal Society Working Group back in 2015 that reported in 2017. This report was released on 25th of April 2017, and it contains a set of public views on machine learning. And it was engagement with members of the public back in 2017 when most people didn't really know what machine learning was, asking what they wanted out of it. And in general, we have various titles. They use examples to share what machine learning could do. And for each case study, the public could see pros and cons. These were case studies in things like health, social care, marketing, transport, finance, or even supportive algorithms in finance, crime. And in each case, the public demonstrate, when they're listened to, when they're spoken to correctly, and not patronized, that they have a really good understanding of the pros and cons of these technologies. Education being one that's very, excellent. The one area that the general public felt was pointless was the last example. Art, and I'll read from it. Art. Participants failed to see the purpose of machine learning written poetry. For all other case studies, participants recognized that a machine might be able to do a better job than a human. However, they did not think this would be the case when creating art, as doing so was considered to be a fundamental human activity that machines could only mimic at best. And so what have we done since 2017 as a community, as our undoubtable progress across these areas where they asked for our help? Well, now we can ask ChatGPT to write a soliloquy that introduces what a large language model is like, as spoken by Mercutio. And it does probably a better job than any human can do. The one thing we managed to recreate is what they asked us not to do. Okay. This is called the Chicago Stone. It's side 2 of the Chicago Stone. And it shows the sale of a number of fields from an early dynastic period in Mesopotamia. It's about 2600 BC. So I don't know, I don't know if there's anyone here from Iraq, but, if you go back to the history of civilization, you're talking about the history of writing dating back to 3500 BC. So the time at which this stone has been written, there's already 1100 years of written history, including the tales of Gilgamesh. It takes about another 1400 years for the Greeks decide to invade Troy, right? And then another 400 years after that they learn to write again, they've forgotten once, and write down those stories, right? So this is very old stuff. But the interesting thing about it is that most of these things are not poets. They're like accounting spreadsheets, or they're legal codes, or they're legal judgments. They're the records of administrations, because writing is introduced to administer the large cities that are forming as people learn to irrigate and they take advantage of the grains that are giving them production, but now they need to build supply chains, so they bring wood down the river to fund their cities. What happened to the people who invented writing? They became very powerful. They became the scribes, the people who could administer the city. In Europe, up until the 15th century, they were the clergy. The clergy, the reigning monarchs were dependent on the clergy because the clergy were the people that administered things. They were the only ones that could write. There's a wonderful book about what that means, because in the modern society, we have the professions that emerge from the people that control that information infrastructure. The lawyers, the accountants, the people that have these duties that are beautifully described in the opening chapter of this book that I think is about 2015. It's been updated now. But the premise of the book is that this modern wave of AI is going to affect professional jobs. And there's some things in that premise I find interesting and some less interesting, but we looked at the book as part of this Royal Society report. And the thing that really stuck with me is in the opening chapter, how the authors describe the responsibility of the professions. The professions are doing two things. One, they're providing a sort of like an enclosure that in order to do this job, you have to pass some qualifications, you control access. But once you've controlled access to the job, there comes a responsibility, and that responsibility is associating with protecting the vulnerable people in your population who understand less about law, and that responsibility comes with your power. Now, the challenge that we're facing around the computerized society is best summarized this notion of intellectual debt. So the notion of intellectual debt is the following. So technical debt you may be familiar with. Jonathan Zittrain describes intellectual debt as the following challenge, that we are building large-scale computer systems that even the creators, even if they're functioning correctly according to specification, don't understand. And there was a wonderful example of that around the US, wonderful example, an example of the problem around the US election, where the day after the election, Mark Zuckerberg said it was a ridiculous idea that fake news on Facebook had played any part in the election. And 10 months later, in front of a congressional inquiry, Facebook's lawyers explained how 126 million Americans had been exposed to misinformation propagated by the Internet Research Agency, a St. Petersburg, I think, based Russian troll farm. And of course, the reason Zuckerberg said that is he didn't know, because he didn't understand his own system and how it was being manipulated by bad actors. So this is the sort of challenge we face now, is we are creating a new information infrastructure that even the creators, who are not subject to the responsibilities that professions are subject to, do not understand or control. And through doing that, we're undermining groups across our society. So I'm going to make sure I get on to the end, so skip through a few slides and give time for questions. So technical debt is the ability to maintain your complex software system, and intellectual debt is the inability to explain your software system. So when you look at going all the way back to Mesopotamia, what those people were doing, they were enabling societies to communicate and manage their aspects. Over time, this involved the introduction of legal codes such as the Code of Hammurabi, 1700 BC, which does include trial by ordeal as point number 2. But today we have more established systems of justice that rely on human decision-making because humans understand other humans' vulnerability. So our modern systems of justice include things like juries, trial by your peers, people who can understand the challenges alongside the professional. Very complex, highly integrated systems that are definitely not perfect, but embed many of the, or deal with many of the tensions there are in managing society. The situation we face today is best represented by this picture, because the picture I'd like to share is not yet out of copyright, because this is a picture of Goethe's Sorcerer's Apprentice. And Sorcerer's Apprentice is the story of a young sorcerer, as played by Mickey Mouse in a later version, alongside Ducas's music, which goes as the mouse, the apprentice, takes one of his master's spells and decides to cast it to do his chores being carrying of water. And as he casts that spell to carry water, he starts to realize he can't control that spell. So too much water is carried, he tries to cancel the spell, he cuts up the wood. If you've seen the Fantasia movie, you know what happens, water everywhere. Now, it all ends happily because the sorcerer turns up and waves their wand and says, Besen, Besen, seid's gewesen, which I think means broom, broom, that's enough. And the broom stops. Now, what we have going on in our society at the moment across our information infrastructure is Sam Altman, Mark Zuckerberg, reprising the role of the sorcerer's apprentice, casting spells that they did not develop, that they are not responsible for the intellectual activity of. They read the spell book, they cast the spell to do their chores on society, and when there are these consequential effects on society, the problem we face is that the sorcerer themselves has been undermined by the casting of the spell. So the sorcerer in our case was described, Fantasia I think is released in the early 40s. This book was conceived by Karl Popper in 1938 when the Nazis invaded his home city of Vienna, which at the time was a cradle of liberal democratic thinking. And Karl Popper was in exile in New Zealand when he finished the book. And the preface to the book opens with these words. If in this book harsh words are spoken about some of the greatest among the intellectual leaders of mankind, my motive is not, I hope, to belittle them. It springs rather from my conviction that if our civilization is to survive, we must break with the habit of deference to great men. Great men may make great mistakes, and as the book tries to show, some of the greatest leaders of the past supported the perennial attack on freedom and reason. From a philosophical perspective, he's particularly attacking Plato and the notion of Plato's republic, this idea that you have these dictators who are sort of benefactorial. And what he says is the alternative is the open society. And the open society, he tells us, is dependent on many actors within society's ability to do the right thing. So what he calls piecemeal social engineers. So people who are in the position of being a lawyer or an accountant or whatever, in any position in society, who know what we're trying to achieve as a society. I mean, what we're trying to achieve is distributed across all people. No one person knows it, and act in the best interests of society to move things forward. The reason that works is you get a sort of resultant force, don't you? You know, if people are just acting in their own interests, that dissipates. But it works if people can operate in that way to get a resultant force. How it gets disturbed is when someone thinks that they have a better idea and they think, oh, well, these things can just be pushed to one side. And of course, there's many problems in society today, no doubt. But the problem is you push these ideas aside, these older systems that sometimes look inefficient, you fail to realize their functionality. And you undermine that functionality in how they provide support for society. We've gone into this sort of weird, obsession with how efficient companies are. Companies are only good at what they do because they don't do anything difficult. They don't do social care. They don't do health. They don't do defense. They don't do education. They solve problems that you can make money from because they are not the problems that people listed in those first 8 examples. They solve problems that people didn't know they had. Like, you didn't know you wanted to look at cats on a mobile phone, but you do, and we've solved that now. It's great. It produces lots of things companies can do. But certainly companies at scale do not solve the problems of individuals and small groups in society. They don't have the capacity to. They operate as these large artificial intelligence systems that try and solve for the largest problem for the greatest amount of money. And by disempowering the people who are responsible for solving those problems, the piecemeal social engineers, they are undermining the fabric of our society. There is no technical existential risk from AI, but there is a societal existential risk that we are all experiencing the challenges of right now as we go into populist elections in Europe. Who does this affect? Well, the Susskind and Susskind book was about how this is going to affect the professions and the poor old professions, etc., etc. Now, my argument is that may be the case, but as professionals, they are equipped to deal with change. They are educated people who can find new opportunities and be flexible in their jobs. The truth is that this affects people who are already on the edge of society, people who don't have choices about what they go and do next. So this is my sort of coin pusher model of how things happen. So yes, the coin falls. I don't know if you've played these. I used to love these when I was a kid. You put a coin in, it drops down, and the idea is that this shelf is moving back and forth, and the coin falls at the back and it disrupts the coins on the edge. They fall down, you collect them. In this case, yes, the professionals may be the ones that fall at the back, and they may shuffle, but at the end of the day, it's the people who are already on the edge of society, who were already promised, this is your future career, go and learn how to be a coal miner or a steel worker or any of these things and you'll be fine, that now we take these pieces of work away. You can be a taxi driver or a call center operator, and then they just get pushed further and down until there are no choices left. And you can see this in the UK most recently. I don't know if you heard about this scandal, but this is a big scandal. One of my favorite things about this picture is this is Jess Montgomery, who sat over there. She's not the one in the dock. She was clerk for this British Select Committee. So this is British Parliament examining a scandal, which was a 1990s deployed digital accounting system for the UK Post Office. So no miracles behind what should be going on here. It's just a digital implementation of what that Chicago stone showed, just being deployed 4,600 years later. And the idea was that up until this moment, the sub-postmasters, who were the people who run post offices that are in rural locations, did their own accounting. So they did their own books. They handed in their books. And they were held responsible if they got the accounts wrong. This was then replaced with a digital system, which those sub-postmasters had to interact with, but the system was filled with bugs. It was an early distributed system, so there was a message passing component to it, and they didn't define the messages correctly. And so if you're a sub-postmaster who is in, this is my best understanding, if you were a sub-postmaster who was in an isolated rural post office, and you lost connectivity, these were ISDN lines, or power, then the sort of complex messages that came up to deal with the failure of persistence that we also know about in modern software engineering tended to be where bugs occurred. So then they were accused of false accounting. Many of them went to prison. Some committed suicide. The saddest bit about it is the people you see here had been campaigning, I think, at this stage. Jess, how long had they been campaigning? This is 2015. Years, like for decades, to get justice. And the reason they couldn't get justice was because the lawyers and accountants who were supposed to protect them were told the computer is always right, just ignore these people's complaints, they're in the wrong, prosecute them. And it's only recently that these convictions are being overturned, after many of them have died. Also, massive loss of reputation. These are people who lived in communities that when these accusations were made, these people were put on the front of the local paper with headlines saying, local postmaster steals from old age pensioners in village. These were people with the heart of that community. Their whole lives were dedicated to serving these small villages. And of course, no AI involved, just crap computer science. And what is AI at scale but really crap computer science? Okay, so I've got sort of other things I could have talked about, but I'll just finish on this sort of last point. There is promise here. And I want to introduce this promise here by introducing an early computer. Now, this is an analog computer built by a guy called Bill Phillips, completed in 1949. And it was designed to simulate the workings of the UK economy. So what is an analog computer? Well, you might think of analog, analog's not digital. Well, actually what analog means originally is it computes by analogy. So the way this is computing the workings of the British economy is that these tanks here are representative of amounts of money. I think this top one is the Treasury, the UK Treasury. And the valves in the tanks that allow the water to move around, it's coloured water, are the movement as if you change tax rates and you move things into education and so on and so forth. So it was a very simple computer where you could change tax rates, and there were floats which also moved other valves. And it's called an analog computer because water flows and money flows, right? So it's computing by analogy. And early analog computers, mostly electrical, but some mechanical ones, lots of firing computers used in ships, a lot of radar work in the Second World War around that. They all have like physical quantities, states in them that are analogous to some state of interest, like whether it's the position of a ship, the amount of money in the economy, and the analogy works because there's some underlying physics that mirrors the two. So that's an analog computer. So what I would argue is when we think of ourselves as AI people, this is the link that we're actually talking about. We're talking about the interface between us and the machine. I still think of this as sort of being data science, and data science sits here as well. And what I think we have now built, which is exciting in many ways, is what I think of as the human analog machine. We have not built a form of intelligence. What we have built with large language models is equivalent to that analog computer. But instead of its analog states being liquid states reflecting money, the analogous states are analogous to the way we view the world in our heads. And that's come to us across our education and across thousands of years of cultural experiences, the way we view the world. It's come to the computer by it trying to reconstruct our language, it trying to reconstruct the next word. And it just turns out, in that sort of Shannon way, to do that well at some point. I mean, this was quite surprising. I don't think anyone predicted this. At some point, in order to do that, it actually reconstructs the concepts that we used to write those words in the first place. But just like those set of tanks of water are not the economy, and at some point they fail because it's only an analogy, the same is true for these human analog machines. And much of what you see in the debate around these things right now is, I think, stemming from the fact that this is why they hallucinate, because they're just creating these analogous states, they're doing things at scale. But they do present an extraordinary opportunity. And the extraordinary opportunity is the following. They provide a new interface between the human and the digital computer. We should never conflate these two, I feel, because the digital computer itself is interesting and it's programmable and it's logical and we can prove things about it as we analyze, whereas the human analog machine is fallible and making crap up, But it is providing a way for regular humans to talk to computers. It's providing a route to do what the printing press did in the 15th century, which is to break the stranglehold of the scribes, who today are the software engineers, and their guilds are the big tech companies. And by breaking the strangleholds of the scribes and returning power to the individuals, the piecemeal social engineers that manage society, I think we can bring about a much brighter future. Of course, things could go the other way. The history of writing is not a history where writing got simpler. We were lucky in Europe that we picked up writing from the Phoenicians. The Greeks got it from the Phoenicians. The Phoenicians were traders. So we got like some shorthand, something that people were using for convenience. And we got that right from the start. In most societies, the scribes maintained the complexity of writing, not consciously, they're just incentivized to do so. You know, the equivalent of sort of forcing everyone to use COBOL to code because that's the official language of finance and government. They did that. They said you have to use these complex scripts. They have to use hieroglyphs for proper writing. In Korea, I think still today, you probably have to use Chinese script for official writing, and the same in Japan. Is it? They do. It was invented in the 15th century. And what did they call it? Women and children's writing. So it was invented, there's two forms of alphabet in Korea. It's the most elegant in the world, according to the book on the history of writing I read, the Korean form, but the official writing maintained itself as Mandarin script. So you couldn't become a scribe by learning the simple form. They kept you out. And this happened in many cultures. I think also Japan has something similar going on. We were lucky that we had the simple script come to us in Europe first, right? So, and you see the same thing, the same effect now going on with AI. Only big tech can control it. It's a scary technology. You have to leave it up to us. And it's not because they're evilly thinking this. They're just incentivized to say that. It is so important that organizations like ELLIS, who are bringing together, I hope, at our best, industry, government, these problems, who are working on these problems of health, social care, education, the problems that people care about. It's slower and harder for us to make progress because we're not just talking about cats on TikTok. We might do that occasionally, but we're not just doing that. We're trying to solve the harder problems with far less money than the big tech companies have. But these are the problems that will advance society, and we must make sure that these capabilities are being shared across society, not in the hands of the scribes, not in the hands of the few, because the biggest problem we have is while we have this new generation of scribes, they have none of the responsibilities that our modern institutions, such as lawyers, accountants, flawed though they may be, doctors, teachers, etc., have. And with that, I'll end. Thank you. How much time do we have for questions? 5 minutes, there we go. 5 questions or 5 minutes? Questions? This one here.
So thank you for the great talk. So given that you talked about theory of mind, like, you know, trying to model each other, do you think the solution is that we have AI or robots that are capable of modeling humans? Should we go from that path forward?
I think in effect, that's sort of what's happening with large language models with some cultural concepts. And I think I think they do have to interact with us. They'll have to second guess us because we expect entities to second guess us, yeah.
Okay, thank you.
So, thank you. You talked a bit about, like, you know, how machine learning can, I mean, every like, let's say, computer science sometimes cannot predict how humans are thinking about others human, but sometimes, I guess, for most of people here who doing research, and like main question is like, what is your, let's say, feeling about why machine learning made this decision? And sometimes you don't have exact answer.
Yeah.
Sometimes you have to really think, like, you know, during the night, like, and wonder why and how it came out with this conclusion. So shall we trust machine, or shall we just ask ChatGPT to say, so what do you think, why I got this conclusion? Because sometimes it's challenging for us even to understand why results are like this and, you know, tendencies like this. Thank you.
I think it's interesting, but it becomes very contextual. I think, first of all, we don't understand why other humans are making decisions, but for years we've evolved to sort of get through that, right? Which is, and we don't understand how we're doing that. And it's really important we work on that piece. But then I think, my main point when it comes to the when we look at these machines, that I think we're undermining people's affordances. So the way people want to understand something is they want to know, if I do this to it, what will it do in response? That level of understanding. And yet we're coming out with these ridiculous notions of explainability that are nothing to do with that. They're nothing to do with that because you can only see what that's going to be in deployment. You have to get closer to deployment to understand how someone's trying to use the technology. It's like trying to imagine how someone's going to drive a car after you've built the engine. There's certain properties of the engine that might be important, but you actually only find out a lot of those when you understand it's about the torque and the drivability, because this engine is going to be deployed in a plane or a vehicle. And the obsession we've had at the moment, driven largely by the big tech companies doing a lot of press around their exciting inventions, is that we intervene at that point. Whereas actually, I think that the truth is that you need the capability to be deployed close to the usage, because the type of how do we want to understand something? We want to sort of know how to sort of control it, how to steer it, how to use it as a tool. If I do this to it, how will it respond? And I think that you have to be working with someone who's trying to use it before you can have that type of understanding.
First of all, thank you so much for the keynote. It was super interesting, and you're a really eloquent speaker. I wanted to ask about your clergy analogy that you were referencing, and you said at some point, we started to learn how to write. Do you think that, because at the moment in technology, we also develop a lot of interfaces that are becoming more and more user-friendly so that we can engage with technology. However, this is still being created by coders in the background. So do you think that we as a society will start to learn the back end of coding the way we did writing, or not?
So I have a great provocation for that. It's like when people are saying this is going to be an AGI and they're going to do all these extraordinary things, my answer is just eliminate the software engineer. We don't need anything else, thank you. If this can be an artificial general intelligence, no, just eliminate the software engineer, which is kind of my provocation, trying to say the same thing as you're saying. If it's got that capability, then take us out, take all of us out as being the middle person between the person who's trying to achieve something and the machine, because we're the scribes. So if it's got those capabilities, please just work on that and everything else will fall into place. But that's working to eliminate themselves, so they don't want to do that. But I do think that's kind of the sort of thing I'm thinking about. I'm not even sure it's possible to do that. I think we should probably need some people as professionals in that domain. But yes, absolutely, working towards a world where people can project their ideas onto the machine in the same way that they can project their ideas onto a piece of paper at the moment, that it's that easy. Very complex, difficult task, but I think that's an important thing.
So then you think people will become kind of prompt engineers in that we learn how to use the tool, assuming it works?
It would be terrible if we're just prompt engineers, wouldn't it? But, I don't know. It becomes too difficult to sort of see, but I think that's the sort of direction that we should be trying to go into. There's clearly some part of it at the moment that's prompt engineering, but that would be a bit, yeah.
Thank you.
Yeah, all good. Time's up, yeah. So I'm going to hand over for the final, much more exciting announcements. Thank you very much.